Good morning, everyone. So, dear student, in our last lecture, we started the second part of mechanical properties of fluid, that is, properties of fluid at rest, and it was surface tension. We studied the basic concept regarding surface tension, starting from molecular force, types of molecular force, cohesive, adhesive, then molecular range, sphere of influence, surface film, free surface of liquid or free surface of fluid which is in contact with the air. Now we have to study the most important article in this chapter. It is surface tension on the basis of molecular theory. We are moving towards actual definition of surface tension. So before we learn the actual definition of surface tension, we have to understand what is the concept of surface tension on the basis of molecular theory. Actually, I explained that surface tension is just a property of fluid by which it tries to minimize its shape, but how it happens, that we have to define as a definition of that surface tension. Before that, we have to study the concept of surface tension on the basis of molecular theory. There may be a question for 3 to 4 marks in your board exam. Explain surface tension on the basis of molecular theory. So you have to draw such a figure. This figure is separately asked for 2 marks, and in question it will give you about 1 mark. So it is the figure which we have to explain initially. Consider a liquid just like water in a container. Consider 3 molecules, molecule A, molecule B, molecule C of the liquid inside a container, such that the molecule A is completely inside, or you can say well inside the liquid. Molecule B is just below the surface of liquid, and molecule C just on the surface of liquid. So the different positions of the molecules which we have considered here, molecule A is well inside the liquid or completely inside the liquid, molecule B just below the surface of liquid, and molecule C just on touching the surface of liquid, you can say. So now you have to explain the molecular theory, the concept of molecular forces, sphere of influence. These are sphere of influence of each molecule. So you have to explain for each molecule. So number 1, we can say for molecule A, the molecule A is completely inside the liquid, means the sphere of influence of molecule A is completely within the liquid. So from all sides of the liquid, all sides of molecule A, there are the molecules of liquid which exert a force on molecule A. Molecule A itself is a liquid molecule, and it experiences force by surrounding or neighboring liquid molecule. Certainly that force is which type of force? Yes, it is cohesive force. So it is equally attracted from all sides by the liquid molecules, and that force of attraction is cohesive force. As it is equally attracted from all sides, the net force acting on molecule A is 0, and that is why molecule A remains steady, remains stationary, or it is at rest at its position well inside the liquid. So this is for molecule A. कसे एक्सप्लेन करणार? सरफेस टेन्शन ऑन द बेसिस ऑफ मॉलिक्युलर थिअरी आपल्याला एक्सप्लेन करायचं. त्याच्यासाठी फिगर आहे, फिगरचं 2 ओळीमध्ये एक्सप्लेनेशन करणार. कन्सिडर अ लिक्विड एनक्लोज्ड किंवा केप्ट इन अ कंटेनर. एक लिक्विड आहे, एका कंटेनरमध्ये ठेवलं, त्याचे 3 मॉलिक्यूल घेतले लिक्विडचे. मॉलिक्यूल ए पूर्णपणे मध्यभागी आहे पाण्याच्या, मॉलिक्यूल बी जस्ट सरफेसच्या खाली आहे, आणि मॉलिक्यूल सी सरफेस वर आहे, लागून पण सरफेस वर आहे. त्याच्यापैकी पहिल्या मॉलिक्यूलसाठी ए साठी, ए मॉलिक्यूलचा स्फिअर ऑफ इन्फ्लुएन्स हा पूर्णपणे पाण्यात आहे. याचा अर्थ त्याच्या आजूबाजूला सर्व मॉलिक्यूल्स कशाचे? पाण्याचे. ते सर्व मॉलिक्यूल्स ए वर फोर्स एक्झर्ट करतील अट्रॅक्शनचा. कोणत्या प्रकारचा असेल तो कोहेजिव्ह टाईपचा. इक्वली अट्रॅक्टेड सर्व बाजूने असल्यामुळे त्याच्यावर काम करणारा रिझल्टंट फोर्स हा 0 असेल. त्याच्यामुळे मॉलिक्यूल ए हा पूर्णपणे पाण्यामध्ये राहील. हे झालं एचं एक्सप्लेनेशन. नाउ फॉर मॉलिक्यूल बी. For molecule B, see here, molecule B lies just below the surface of liquid. The surface of liquid is in contact with the air, it is called as free surface. So that molecule B is just below the free surface of liquid, you can say. So one thing must be clear here. The sphere of influence of B, as we draw there, it lies partly in air, and major part of sphere of influence of B lies in water. याचा छोटासा भाग जो आहे वरचा तो हवेमध्ये आहे आणि जास्तीत जास्त भाग पाण्यामध्ये आहे. म्हणजे त्याच्या आजूबाजूला जास्त मॉलिक्यूल कोणाचे असतील? पाण्याचे. सो the sphere of influence, part of sphere of influence of molecule B, small part lies in air and major part lies in liquid. So it experiences a net cohesive force due to molecules of liquid in downward direction, but there is also a small additive force due to molecules of air, but that molecules are very few in number as compared to molecules of liquid. So therefore the force exerted by molecules of liquid, that is cohesive type of force, is greater than the additive force exerted due to molecules of air. Therefore, which one is greater force? It is cohesive force. So effect by vector, in vector chapter we study the resultant force acting will be always in the same direction as that of the quantity having larger magnitude. So here cohesive force is greater in magnitude. So net force acting on molecule is also in downward direction. So all the molecules close to molecule B or at far distance also within the surface of liquid from point B, they are also poured in downward direction. Now for molecule C. For molecule C. See here carefully for molecule C. So molecule C is on the surface of liquid. Certainly it is molecule of liquid, but just it is on the surface of liquid. So its sphere of influence lies, half part lies in liquid, half part lies in air. So it is attracted by two type of forces. One is additive force due to molecules of air, and second is cohesive force due to molecules of liquid. So what is the number of again attracting force, magnitude of attracting force? As far as density is concerned, liquid has more density as compared to gases. Therefore molecules of liquid are more in number which attract the molecule C as compared to the molecules of air which attract molecule C. By which force? Additive force. So which force must be greater than again? Yes, cohesive force is greater as compared to additive force. Additive force is due to molecules of air which are few in number as compared to that of liquid as far as density is concerned. So again molecule C experiences a net force. It is also acting in vertically downward direction. See here this layer, actually this is molecular range, and this molecular range we consider as thickness, and that layer of liquid having thickness equal to molecular range is called a surface film. So in the surface film all the molecules of liquid are attracted in downward direction, and therefore that film, that surface of liquid, layer of liquids which are in the surface film, we can say it acts like a stretched membrane, just like it is under a tension, and that tension is called as surface tension. So this is surface tension of the molecular theory. What happens here? Carefully see. बी मॉलिक्यूलचा स्पियर ऑफ इन्फ्लुएन्स जो आहे तो मेजर पार्ट लिक्विडमध्ये आहे, थोडासा पार्ट हवेमध्ये आहे. मॉलिक्यूल हवेचे थोड्या संख्येने असतील त्याला अट्रॅक्ट करणारे, जास्त संख्येने लिक्विडचे म्हणून त्याच्यावर काम करणारा मुख्य फोर्स कोणत्या दिशेला असेल? डाऊनवर्ड. कोणता? कोहेसिव्ह. सी मॉलिक्यूलसाठी अर्धा स्पियर ऑफ इन्फ्लुएन्स हवेमध्ये, अर्धा पाण्यामध्ये, पण पाण्याचे मॉलिक्यूल जास्त संख्येने असतील म्हणून त्याच्यावर नेट फोर्स काम करणारा तोही डाऊनवर्ड डायरेक्शनला. मग त्या सरफेस फिल्म मध्ये ही सरफेस फिल्म किती रेंज किती थिकनेसची? मॉलिक्युलर रेंज इतके थिकनेसची. त्या सरफेस फिल्म मधल्या प्रत्येक मॉलिक्युलवर फोर्स काम करतो, तो असतो डाऊनवर्ड डायरेक्शनला. कुणामुळे? त्या सर्व मॉलिक्युलमुळे. मग ते प्रत्येक मॉलिक्युल असा खाली ओढला जातो. म्हणून ती सरफेस फिल्म जो लेअर आहे तो जस्ट लाईक अ स्ट्रेच्ड मेम्ब्रेन, ताणलेल्या पदरासारखा, ताणलेल्या सरफेस सारखा काम करतो, पडद्यासारखा म्हणू शकतो आपण, काम करतो. आणि हे ताण कशामुळे आला? तो जो ताण आहे त्यालाच म्हणायचा पृष्ठभागावरील ताण, त्याला म्हणतात सरफेस टेन्शन. So all the concluding part here, all the molecules in the upper layer, that is surface film, experiences a force in downward direction, that is cohesive force, and due to this force of attraction in downward direction, the film behaves as it is under a stretched membrane under a tension, and that tension is called as surface tension. Now we have to study what is surface energy. If we have to bring the surface, that is molecules from lower surface to the surface field, what we have to do? We have to do work against the cohesive force which is acting in a downward direction, and in doing so, to bring the molecules in the upper surface, we have to perform some work, and that work is stored in the form of energy, potential energy in this film, and that potential energy is called as surface energy. So this is again important concept, surface energy. What we have to do? If we have to increase the surface area of liquid in contact with air, means we have to increase the free surface of liquid. We must bring the liquid molecules from lower side to the surface, and to do so we have to apply some force against the cohesive force. And if we displace the molecules from lower surface to upper surface, under the action of force, there is a work done, and that work done is stored in the form of potential energy in the surface film, and that potential energy stored in the surface film is called as surface energy. So this is surface energy, concept of surface energy. So in increasing the surface of liquid in contact with air, we have to bring the molecules from lower side, and that requires work done, and that work done is stored in the form of potential energy, and that potential energy which is stored in the form of surface film is called as surface energy. So this is the concept of surface energy. So this is surface tension on the basis of molecular theory. We have to explain the condition, position, and the force acting on each molecule at their respective position. Molecule A well inside liquid, molecule B just below the surface, molecule C on the surface. So this is surface tension on the basis of molecular theory. In next lecture we will define the surface tension, and we will find the relation between surface tension and the surface energy.